All right, combinations. A collection of items from a given set where order does not matter. Permutations, order matters. Whether I give someone the drug first, second, third, or fourth matters, because once I've used it, I can't use it again. A combination doesn't matter the order. If I pick it first, second, third, or fourth, it doesn't matter as long as I've already got it. It's just a part of my set. It doesn't matter whether I pick it first, second, third, or fourth, for example. Notation for combinations looks a lot like permutations, except I'm using a letter C in place of R. How many combinations from a set of n items can I choose where I need R of them in total? Sometimes I say this as n choose R. N choose R. From a set of n things, how many ways are there to choose exactly R of them? So let's talk about the formula over here to the right. A combination is the same as a permutation, but I have to divide out all the different arrangements that are identical by dividing by an extra R factorial. The permutation, n permutations of R, this tells me how many different ways in total I can choose them. But I would be counting too many, because I'd be counting different permutations of the same thing. So I need to divide by R factorial to get rid of all the combinations that are identical, because order doesn't matter. As long as it's in my combination, I don't care whether I picked it first, second, third, or last, for example. So this formula right here, n factorial divided by n minus R factorial. This is the formula for permutation from last week. I've just added an extra R factorial to get rid of all the combinations that are identical. The top part tells me the total number of ways. That's what a permutation tells me. How many different ways, how many different permutations from a set of n things are there for R objects? Dividing by R factorial eliminates identical or repeated combinations. All right, I give you the formulas. They're there if you want to use them. But I think it's best to kind of write it out by hand. So let's practice some of this. Got a handful of combinations practice. Mr. Hansen has 9 Hawaiian shirts to take on vacation, but his suitcase only holds 4 of them. How many different ways can I pack for my trip? How many things can I choose from? That's how many things I'm choosing. How many things can I choose from now? So I need 9 shoes from 9 shirts. How many combinations of 4 of them can I put in my suitcase? How many shirts can I pick from first? 9, then second. 8, then 7, then 6. That'd be how many ways in total I could pick the 4 shirts from the 9 in my closet, right? But isn't that counting way too many things? It'd be counting the same 4 shirts, all the different ways that I can arrange them. As long as I pick the 4 shirts, it doesn't matter the order that I pick them in. So I'm going to divide out all the different arrangements that are identical. Repeated combinations of the same 4 shirts. So that would be 4, 3, 2, 1. That's what this extra R factorial does down here. It eliminates all the different permutations that are of the same thing, right? The ones that I'm double counting that look exactly the same. So on Desmos, let's set this up. 9 times 8 times 7 times 6 divided by 4 factorial. So there's 126 different ways for me to pack the suitcase. Here's how many ways in total there are for a permutation of 4 things from 9 different objects. But I don't want to count the same different combinations more than once. So divide by an extra 4 factorial. 126. Does that sound logical? Does that sound reasonable? Good. Okay. Let's try some more. Post-prom committee here at school is made up of any 3 of 6 seniors and 7 juniors. So I can choose any 3 of those different students. How many different 3-person post-prom committees are out there? I'm going to choose 3 from how many different students in total? 13. So I need 13, choose 3. From 13 students, form any combination of 3 of them. How many different people could I pick from first? 13. Then second. Then 11. Now that's counting way too many things, right? Let's just say, for example, I've got person A, B, and C. That's counting person A, B, and C as one committee. Then it's counting person B, C, and A when I pick them in that order as one different committee. But isn't it just the same 3 people? I don't care if it's the same 3 people. They're just in the committee. It could also be C, B, A. So I need to get rid of all the arrangements that are exactly the same people. So I need to divide by an extra 3 factorial. 3 times 2 times 1. 13 times 12 times 11 divided by 3 times 286. Let me show you a couple more, and I'll finish what's on your. Let's pull cards. You play 5-card draw or 5-card stud. You're going to get 5 poker cards, 5 cards drawn from a standard deck delivered to you. How many different 5-card poker hand combinations are possible? How many cards are in a deck? I need to choose how many of them. So 52, choose 5. How many different combinations of 5 cards dealt to me are there possible from a standard deck of 52 cards? All right, so let's see here. I could pick one of any 52 cards first, then 51, 50, 49, and 48. But then I have all the different card combinations counted more than one time from the same 5 cards. So what do I have to divide by? 5 factorial, 5, 4, 3, 2, 1. Divide by an extra 5 factorial, like you're seeing here, to get rid of all the different 5-card hands that I'm counting more than once from this permutation up above. So it looks like there's just a shade under 2.6 million different 5-card combinations from a standard deck. 2,598,960. All right, this one is going to be a little bit different. Let me turn your attention to this last one, and we'll start getting some calculator stuff out. How many different 5-card poker hands contain 3 aces? What do the 5 cards in my hand have to look like according to that statement? What does my 5-card hand look like according to that statement?
Had any card twice, then 3.
So I have 3 aces and just any other 2 cards, right?
Yeah.
So I need 3 aces and 2 non-aces. 3 aces would be 4 choose 3 because there's 4 aces. I need any combination of 3 of them. What's the combinatoric for the other 2 cards? How many non-aces are in a deck? How many cards are not aces? 48. The other 48. So let's multiply this times 48, choose any 2 to complete my 5-card hand. I need exactly 3 aces, so the other 2 cards just can't be the other aces. So 4 choose 3 would be 4 times 3 times 2. But isn't that counting too many things? What would I have to divide by? 3 factorial. Because I don't want to count the same set of 3 aces more than once. So let's divide out all the different 3-card combinations I'm counting more than. Now 48 choose 2. That'd be 48 times 47, but then divide by 2 factorial, 2 times 1. There is your product to figure out how many different 5-card hands contain exactly 3 aces. So 4 times 3 times 2. Actually, this one you can do in your head. Check this out. What's going to cancel out from top and bottom here? Wouldn't it just be 4? There's 4 different ways to choose 3 things from any set of 4. We got 4 there, which makes sense. Now let's type in the rest. We've got 48 choose 2. So 48 times 47 divided by 2 times 1. Looks like there's 4,512 different 5-card poker hands that contain exactly 3 aces. Okay, does everyone have a calculator? Because a lot of different calculators can do combinations for you. On Desmos, there is an option that says NCR right here. Let me share my screen with you guys, so those of you online can see what I'm talking about. A lot of different calculators can calculate combinations for you using some of their different features. So on Desmos, if I go to the functions menu, there is an NCR option down below. So I can type in NCR, and as long as I tell it what the 2 numbers are, how many things are in the set, and how many am I choosing, it'll do it for me. So 4, 3. Times, I need the other 2 cards to not be aces. So NCR 48 choose 2. It's the same 4,512 we got by hand the other way. Did everyone find where to find that on their calculator? If you use calculator hashtag, I can show you, or if you have a TI calculator. Do you know what yours are at? That same probability. Yours is a little bit different. Right. But you got to put the first number in before you get to C. So say I want to do 4 choose 3. Hit the 4 first, and go back to that combinatorial. Go there, and hit 3. Now let's hit times. I need 48 choose 2. So hit 48 first. 2.
What's up, Mayor? I'm just
Did you
waiting. I'm just waiting to test.
I'll take a seat right here.
Oh, okay, let me go.
You just want to do that?
Yeah, I got you.
That's all right.
Yeah, pencil on the formula sheet, probably a calculator. Thank you.
Yeah.
All right. Did everyone get their calculator with this typed in? Yeah. It's going to save us some time in the future. Everybody online have any calculator problems?
No.
I know. No, we're good?
All good.
Awesome. Let me put one more up here for you. I'd like you guys to try this. Gabe, yeah? Good?
Yep, all good.
Awesome. Let's do this then, if I can find my black marker. So we got this. NFL season is played over 16 games. In how many ways? And a team finished with a record of 9 wins, 5 losses, and 2 ties. Let's practice using the combinatorics feature on our calculator. NFL season is 16 games long. I want to finish with a record of 9, 5, and 2. 9 wins, 5 losses, and 2 ties.
We'll be right back. It's not hard. Yeah.
How many games are there to choose from? 16. Let's start with the wins. 9 wins. I need to choose any 9 of the 16 games played to win. Let's do the 5 losses. How many games are there left to choose from? Why 7? I already took away the 9 wins, right? So aren't there only 7 games left to play or decide the outcome of? So what's the combinatoric? For 7 games, I need to lose 5. Should be 7. Choose 5. Of the 7 games remaining, choose any 5 of them to lose. I don't care if I lose all 5 of the 7 to start with. I just need to lose any 5 of the 7 left over, right? I don't care the order in which it happens. Now, how about the 2 ties? How many games are there left to decide the outcome of? What's that? 2. Only 2 left. Doesn't really matter because 2 choose 2 should only be 1. Only one way to choose 2 when there's 2 things in total. Multiply this together. Type that into your calculator. (16) choose 9 times 7 choose 5 times 2 choose 2. Check your work on the television screen, guys. I got 240,000. 240? Did anybody get anything different? Any problems getting that typed into a calculator? Take a second, type that in, check your work. Look at all the 40s. I had 95,040, 5,040, 240, 240. Weird. Strange. Do we have any problems getting that typed in? No. Awesome. Then let's spend some more time working on some practice. Why don't you grab your laptops and open up Unit 4, Standard 14. Everyone good online?
Yeah.
Yeah, like we just had. All right, guys, pull up Schoology here. We're going to get some practice pulled up. I've got Unit 4, Standard 14. There should be a Google Doc that has combinatorics practice problems with the answer key here at the top. Pick up where you left off from last week, please. After about the third or fourth page, there's 29 permutations questions, and it should start over again with combinations questions. Remember where I showed you to find all of these on your calculator. All the permutations practice to start with. If you're ready to start the combinations practice, you can scroll down and find this below. Ready to start, Ethan?
I think I have the same tips.
You go through it right now?
Yeah.
It should just be a calculator or something like that.